To Chapter 4, Financial Arithmetic. Today we begin our very lengthy exercise 4E on time payment agreements. So in general, if you cannot afford to purchase something, whether it be a good or a service, typically it's a good, with cash or debit, sometimes you have the option to purchase it with credit. This is like borrowing, so a loan, but with the intent to pay in full at a later date. Hire purchase agreements, which are the focus for exercise 4E1 or part 1, often give a flat rate of interest, which is the same as the simple interest formula. So interest will be paid as a percentage of the original amount owed. If you would like information on how hire purchase agreements work, please refer to page 194 of your textbook. They give a pretty decent explanation on what they are and how they work, but to save some time, I'm going to jump straight in with the mathematics today. On the screen, you will now see a formula. RF, which is your flat rate, so R sub F, equals 100 times I over PT. This is the same formula you were given to calculate R on its own in exercise 4C, where we were rearranging the simple interest formula. RF, of course, should be a percentage, okay? It is interest. Let's try it with an example. Anna buys a TV for $1,200. She pays a deposit of $300, with the remaining $900 to be paid in 6 monthly payments of $165 each. What is the flat rate of interest Anna pays on the TV? So, to calculate the interest, what we need to do is find the total amount that Anna is basically borrowing, and we need to calculate I. So, if I look over here, I'll do this sort of in 2 steps. RF, R sub F, equals 100 times, well, I don't know what the interest amount is yet, so I have to leave that blank for a quick second. And the principal amount, the total amount that she's paying for the TV, that is here, that is given in the question, 1,200. And we're going to multiply it by time. So 6 monthly payments, 6 months, T equals half a year, or 0.5, okay, years. Remember to always convert your time to years. So I need to still calculate this blank right here, I. And that's what we're going to step through now. To do that, I need to first look at the total amount that Anna paid. So total A, or amount, equals, she started with a deposit of $300 plus $165 for 6 months. So she made 6 monthly payments, or 6 times this payment here. In our calculators, that gives us a total payment. So Anna in total has paid $1,290 for this television. Therefore, the interest paid, I, which is what we need for this bit here, okay, equals, and I'm just going to label that here for a second. This here should be I, okay. The interest paid is the total amount A minus the principal. Okay, remember that I equals A minus P as we covered in exercise 4D. And that gives us the total interest amount of only $90. So Anna in total has paid an extra $90 for this television than if she'd had $1,200 on the day to buy the TV. We then substitute this value here, $90, in for I. And when we plug this into our calculator, 100 times 90 over 1,200 times 0.5, we get 15% per annum. So her interest rate is 15%, or the flat rate of interest is 15. However, in reality, and I'm just going to rewrite that 15% so that we can clearly read it over the new note. My apologies. Okay. In reality, over time and with regular payments, the principal owing ends up being paid off a lot sooner than the end of the agreement. And so you end up paying interest and only interest by the end of the agreement or loan term. So if she's paying $165 a month and only $90 of that is interest, well, we could effectively consider that nearly half of Anna's entire last payment or more than half of it, is only interest, and the 5.5 repayments at the beginning was simply the principal. That's a lot more than 15% if you consider that one of those payments was more than half. Okay, so in general, the effective interest rate, which is the amount that you were effectively paying in interest, is given by RF multiplied by 2n over n plus 1, where n is the number of payments. So generally, this should be twice the flat rate. So if we get about 20% for RE, we know we've done something wrong with our calculations. If we get 50%, we know we've gone wrong as well, because we should get closer to 30 for this figure. So continuing on with the example, what is the value of the effective interest rate that Anna is paying? So we substitute in, of course, to calculate RE, we need to have calculated RF first, which we have, and we have 15. We don't have to put the percentage symbol in. Multiply it by 2 times this 6 monthly payments here. This is your N value, okay? So she is making 6 payments in total, and we substitute 6 for both the numerator and denominator where N is. When we plug this into our calculator, we multiply 15 by 12 and then divide by 7. We get 25.7%, which is pretty close to 30%, so we know that we are on track. Okay, so realistically, Anna is paying closer to 25.7%, and that's because of the nature of the payments that she is making. If you would like to do more research on effective interest rates versus flat rates, of course, you are always welcome to. But here on the screen now is all of the mathematics that you do need to complete the questions for this exercise. As always, if you have questions, get in touch with me and I'll get back to you as soon as I can. But otherwise, good luck with the work, guys, and I'll see you all very soon.